Okay, today I'll be covering 1.2 graphical representations of quadratic functions part 1. Okay, just some preamble. When my coefficient of x squared is positive, I have a smiley graph. What I have is a turning point over here, and this is a minimum point. Similarly, if I have a negative coefficient of x squared, what I have is a frowny graph, and here I'll get a maximum point. Okay, now let us take a look at example 5, which asks us to find the coordinates of the turning point and the y-intercept on the graph. So what I've done here is this. In order to find the turning point, the best way is actually to find the completed square form. So I factorize -2 from here as shown, and then I have this is equivalent to this portion here where I've completed the square. Then I have multiplied the -2 in, so I'll get this expression. Once again, this is the completed square form of this equation, or this expression rather. Now, since it is a frowny graph, I will get a maximum point, and the maximum value of y is 6. Okay, to get my x value, as shown in the previous video, I take x minus 1 is equals to 0. My x value is equals to 1. Now, the next thing here is for us to find the y-intercept. For me to find the y-intercept, what do I know? What happens at the y-intercept? Okay, at the y-intercept, I know that my x value is equals to 0. So, for me to find my y-intercept, what I can say is this. I let x is equals to 0. So my y-intercept is equals to 0 into where? This is equivalent to this, is equivalent to this, is equivalent to this. So if I substituted 0 here, 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 or here, you'll all be fine. But I think this form looks the neatest, so I'll substitute it at the right at the end there. So I say 0 minus 1 square plus 6. So what I get is y is equals to -1 square is positive 1 minus 2. This gives me y equals to 4. So my y-intercept is equals to 4 in itself. Okay, now for this one, why don't I just quickly sketch the graph for you. Okay, so if I were to quickly sketch the graph, what I get is the x and y over here like this. I know that my maximum point is 1 and 6. Okay, so my graph will look like this. Okay, it's a quadratic graph like this. And then let me shift the graph a bit. Okay, I will know that my maximum point occurs at 1 and 6. And my y-intercept is 4. So the 4 comes from here, the 1 and 6 comes from here. Now, the next step here is this. They will actually ask us to find the exact values for which y equals to 0. So now what I'm going to do here is I'm going to use this completed square form and attempt to solve this for you. So let me copy this, let me paste it here, and I'll attempt to do part 2 for you now. So they say that when y is equals to 0, so I will say let y is equals to 0. Minus 2 x minus 1 square plus 6 is equals to 0. Then I will subtract 6 from both sides of my equation. I get -6. So here I get x minus 1 square is equals to positive 3. Now, to get rid of my square, I will square root and square root in the left hand side and right hand side. Don't forget that this gives me a plus minus. Whenever you square root a number, or you should get a positive root and a negative root. Hence, what I will say is x minus 1 is equals to plus minus of square root 3. So x is equals to 1 plus minus of square root 3. So the exact values of x, let me write it down here. So my exact values of x are 1 plus root 3 and 1 minus root 3. This is known as the surd forms. We will cover that in a later topic, but when there's a square root 3 and square root 3 here, this is known as an irrational number. So do not evaluate the square root. If you leave it as a square root 3, it gives you the exact value, which is what they want over here. Okay, please pause the video for try 5 and then I'll give you the answers in a short moment. And 3, 2, 1, let's go. Okay, for try 5, what I've done here is similarly to find the turning point, what I've done is I have factorized the 4, I've completed the square. Okay, now don't be alarmed. Negative 9 over 4 plus 9 over 4 gives you 0. So you multiply the 4 in, the 4 ends up here. 4 times 0 still gives you 0. Notice I've written my 0 in red because you don't need to write the plus 0 there. But I write the plus 0 there to help you because very simply, this is a smiley graph. There's a minimum point. So the minimum value of y is 0. I put it down here. So if you don't be alarmed that there's nothing here, it's actually 0 plus 0. So normally we just don't write it, but I will actually leave it there to let you know there's a 0 there. And the x value occurs down here. X minus 3 over 2 is equals to 0. My x value is 3 over 2 or 1.5. Hence my turning point occurs at 3 over 2 and 0. To solve the equation, as you can see, I've already solved the equation over here. I think I missed out something, which is the y-intercept. So let me just write it out down here. So for my y-intercept, alright, let my x value be equals to 0. Let me substitute this into here. You can substitute this into here or here even if you want, but let's not create trouble. So I'll just substitute it into the end. So y equals to 4 times 0 minus 3 over 2 square. So 9 over 4 times 4 will give me 4. So my y-intercept is 9 over 4. So let me write that. My y-intercept, okay, is equals to 2 and 1/4. Okay, now the x-intercepts P and Q enables us to find the line of symmetry. In order for me to find the x-intercepts, what I can do is to actually factorize, okay, and then the factorization will give me the roots where it intercepts the x-axis itself. So this diagram not so clear. This is the x-axis and this is the x-axis. So there's also a new idea here, which is the line of symmetry. How do I find the line of symmetry? Basically, what I'm trying to do is to find the middle line between the two roots over here. So let me give you an example. Let's say I draw a graph here. This graph here is like this. Let's say, just for argument's sake, this value here is 10, this value here is 2, this is the x-axis. If I would want to find the middle value over here, what do I do? What is the middle value of 2 and 10? So this x value or this middle value is known as a line of symmetry. For me to find the middle value between 2 and 10, okay, the value is actually 6. How do I get 6? You just take 2, you add to 10, you divide by 2. So you find the middle number. So the x is equals to 12 divided by 2 is 6. This x equals to 6 is actually known as the line of symmetry. What does the line of symmetry do? The line of symmetry divides the graph exactly into half and half. So it's like a mirror, okay? It mirrors the graph as known as the line of symmetry. And another important point is that the line of symmetry will actually pass through the maximum point, or in this case, this is the minimum point, or in this case, if you use the line of symmetry, notice that it will pass through the maximum point as well. So in an example later, you can see that we can actually use the line of symmetry to help us to find the coordinates of the turning point. Okay, never mind, I'll give you an example first. So for example, x squared minus x minus 12, I've factorized this. So this is the factorized form. So if I let my y value equals to 0, so what I'll get is x plus 3, x minus 4 is equals to 0. My x value is negative 3, or my x value is equals to 4. So if I just use my handy graph over here, okay, I put it here. What I will find is that this value here will be negative 3. This value here will be 4. And then if I want to find my line of symmetry, so let me just put a dotted line down. This is my line of symmetry. My line of symmetry here is I use minus 3 plus 4 divided by 2. I'm finding the middle value between negative 3 and 4, the value between my two roots. So my line of symmetry is x is equals to half. So this line of symmetry, x is equals to half. Okay, example 6. So for example 6, what they want from us here is to find the x-intercepts and the coordinates of the turning point. So first and foremost, what I'm going to do here is this. Y is equals to, I need to express this. When I want to find the x-intercepts, I should attempt to find the roots, or the factorized form, which will help me to find the roots of the equation. So if I factorize 2, I get x squared minus 3x minus 4. Makes my life slightly easier when you factorize. Then the 2 first. What I get is x and x. I'll get here, it will be x minus 4, x plus 1. So what this implies is this, at my x-intercepts, for my x-intercepts, I let my y value equals to 0. So 2x minus 4, x plus 1 equals to 0. So x minus 4 equals to 0, x equals to 4. This is from sec 2, okay. X plus 1 equals to 0, x is equals to negative 1. So if you have seen, I've already drawn, okay, the graph here. Let me start to label, okay. Here, this value will give me negative 1. This value will give me 4 over here. For me to find the turning point, there are a few ways around it. One way is you can go and do the completed square form, but I think that is quite painful, so let's not do that. So the other way around this, what I can do is to find the line of symmetry. So let me use another color now to find my line of symmetry. Let me use purple. Okay, to find my line of symmetry, okay, my line of symmetry will be x is equals to minus 1 plus 4 divided by 2. My x value here is, my x is equals to 3 over 2. So if I draw a line down, okay, so this line of symmetry implies that my x value is equals to 3 over 2. So if you focus, okay, on this point here, I can actually write down that my x coordinate is 3 over 2. My y coordinate is still unknown. So how do I find my y coordinate? For me to find my y coordinate, I can actually use my 3 over 2 and I substitute it into my original equation. Because this x value, 3 over 2, you can find the corresponding y value from my original equation. So what I can do here is my y value, okay, is equals to 2 times 3 over 2 square minus 6 times 3 over 2 minus 8. And my y value in this case would give me negative 25 over 2. So I can plug this negative 25 over 2 into here. So it tells me that my y value is negative 25 over 2. And that in itself is the coordinates of my turning point. So now, if you notice, I've already found these 2 points here are called the roots of the equation. So I've already found the roots of the equation. Now I just need to tell I won't say story. I'll just need, right, to actually make a statement there. So the statement I can make, right, to explain, okay, because they ask you to explain, you need to write words, okay. We'll say this, okay, for the real roots of 2x squared minus 6x minus 8 equals to 0 are negative 1 and 4, which is over here. Then I can say, hence, okay, 2x squared minus 6x minus 8 equals to 0 has 2 distinct real roots. Okay, for try 6, please give it a shot and try it out, and then I will show you the answers in a short moment. Let's go. Okay, first to find my x-intercepts, I will attempt to find the factorized form, not the completed square form. So if I factorize -2, make my life easier, I factorize this into this x minus 2x plus 1. This is the factorized form. Then what I did similarly is I find my x coordinate of the turning point. Actually, this is also the what I call the line of symmetry for this graph here. So what I found is a line of symmetry. This is x equals to half over here. So if x equals to half, I know, okay, that for this point here, my x value is half. What I need to do is to find my y value. So I take my half, I substitute it into my equation. You substitute it here, here, or here is also okay, you still get the answer. So if you're careful, then what I get is 4.5. So here I'll get 4.5. Then next thing they say, explain why this -2x squared plus 2x plus 4 equals 0 has two distinct real roots. So the graph has two x-intercepts, x equals to 2 and x equals to -1 as shown here and here. So therefore, it has two distinct real roots. And this is the end for chapter 1.2 part 1. Thank you for watching.